Find the sum, listed right there. We already have an answer for us. So how did they come up with that? How do they find the sum of that series? Well, remember this right here is a big Greek S. Let me highlight that. This right here, this is a big Greek S. Is all that is. Big Greek S. Kind of looks like an S almost. And it just means sum. It stands for sum. It's a Greek S for sum. And so what it means is you've got to plug in 1 to this formula, then 2, then 3, then 4, all the way to 9. You start at 1 and you end at 9. So let's do that. I'm going to plug in n equals 1 first off. So it's 6 times 5 to the 1 minus 1. Plus, because it's a sum, and then you plug in 2. 6 times 5 to the 2 minus 1. Plus, and then you plug in 3. 6 times 5 to the 3 minus 1. Plus, dot, 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 all the way to the last one where you end, 9. So at 9, it's 6 times 5 to the 9 minus 1. So I just plugged in the n values, 1 through 9. And now let's calculate them. What's this going to be? This is 6 times 5 to the 0. Now what does that mean, 5 to the 0 power? Anything to the 0 power is 1. Are you getting comfortable with that? So 5 to the 0 power is 1. 6 times 1 is 6. Plus, now what's the second one? 6 times 5 to the 1, so that's 30. Next one, 6 times 5 squared, 6 times 25, use your calculator, it's like 6 quarters, it's $1.50, right? Plus, dot, 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 now what's the last one? What's 6 times 5 to the 8th? That's a big number, definitely in my calculator for that. I'm getting 5 to the 8th is 390,625 times 6 is 2,343,750. So this is the sequence that they're actually asking us to add. There it is. I changed it from the sigma notation, right? This sigma notation right here, and we have changed it to be regular notation. Okay, so there's what we're trying to add up. Now, what's happening from term to term? What's going on here? Like, how does 6 become 30? And how does 30 become 150? It's not adding the same number, because that'd be adding 24, and that wouldn't work for the next one, right? You could add 24 there, but then if you added 24 here, it'd only be 54, it wouldn't be 150. So it's not adding the same number. What's it doing? It's multiplying by 5 every time, of course, huh? That's that 5 right there. We can see, right? This has 5 to the 0, 5 to the 1, 5 to the 2, all the way to 5 to the 8. It has another 5 every time. It's multiplying by 5 from term to term. So when you're multiplying by the same number each time, what does that mean? Are you arithmetic or geometric? That's geometric, isn't it? That's a geometric sequence of terms. Now, and then we want to add them up, so we need the S sub n formula for geometric, right? So that's going to be, what is it? A1 times R, I'm honestly forgetting the geometric formula here for a second. Oh, I remember. Okay. A1 times 1 minus R to the n over 1 minus R. There we go. Okay, so there's the formula for the sum of a geometric sequence. So let's plug everything in. A1 is the first term. R is the ratio, meaning it's the second term divided by the first term. Or the jump, same thing as saying the jump from term to term. And n is the total number of terms. Okay. So let's see, A1, the first term, that's easy, that's 6, isn't it? So the first term is 6, and 1 minus, now what's R? What's the ratio, the R? What's the second term over the first term? What's the second term? 30, divided by the first term, which is 6, and that's 5. And of course, that is the jump from term to term, right? It's going times 5, times 5. That is the R. We could have just looked at that and said, well, that's your R. That's what's happening. Or you could take the second term divided by the first term. Or the third term divided by the second term. Any term divided by the previous term will give you that jump of 5. So the R is 5. To the N. Now what's the N? N is the total number of terms. How many terms do we have here? Well, we're going from 1 to 9, right? From 1 to 9. So there's 9 terms. That goes right there. That goes in the in spot. So there's our formula. So S sub n is 6 times, and then use your calculator, 5 to the n. That's going to be big. I'm getting 19531. 5, so that's that, over -4, 1 minus 5 in the bottom. So that's 6 times minus 1953124 over -4. And when I divide that, the two negatives make a positive, and I get positive 488,281. So then finally times 6, I'm getting 2,929,686. So I'm hoping, is that the right answer? 29, is that what they got? Yeah, 2,929,686. 2,929,686. There we go. That's how you find the sum of those terms. So that sigma notation, that Greek S, you just write them out. It's 9 terms. Starts at 1, goes to 9, write them out, then use the S sub n formula and plug everything in.